We're going to take all of the knowledge we have from the previous lessons and formulate a bash script, just an automated way to execute multiple commands and perform some function. The script that we're going to use is one that I've written called passparser.sh. You would never use this script in the real world since it doesn't do anything particularly useful. However, it does demonstrate several features of bash that you'll commonly encounter when writing real scripts. Passparser.sh, all it does is read the /etc/passwd file, each line at a time, sort it by user ID, and print the output in a very specific format. You can refer to the man pages anytime you're confused about the syntax of any commands used within the script, but we're going to go through it line by line. So first, we want to check what the permissions on the script are. In order for a script to execute, it must have the executable bits set. We haven't learned about file permissions yet, but let's quickly look at the permissions on this file. If we run ls-l, we see a lot of output on this command line. In particular, we're interested in the beginning of the line. We see several rwx. This means that the file is readable, writable, and executable. The first three are for a user, the second three for a group, and the last three, which doesn't have a W, is for everybody else who might use the system. We're going to go through that in detail later, but importantly, the X is turned on, meaning that this file is ready to execute. Now let's see what the output looks like. We'll remind ourselves first by looking at the raw etc/passwd file. Remember that it contains a list of users with a colon-separated field. If we run our script, which we preface with // indicating that we wish to run the script within this directory, the thing that it does if we don't pass it any arguments is give us a usage statement. This is very common in Linux systems. The usage statement indicates what flags and arguments you need to pass to the script. This takes /etc/passwd as its only argument. What happens if I try to pass it two arguments, like etc/passwd and then the number 1? It also prints out the usage statement. So it's doing some smart things about checking the flags. So let's pass it what it's expecting, just the etc/passwd file. It prompts me, do you wish to parse etc/passwd? And then it indicates that I should type yes or no. I'm going to type something else, blah. It prompts me again, do you wish to parse etc/passwd? Yes, I wish to parse it this time. So we can see that it looked at the output of /etc/passwd and printed the output in a very specific format. It says that the user root has UID 0 and has home directory /root. Let's look at how it worked. I'm going to open the script with VI. We'll start at the top. The first line indicates that this script should be interpreted with the bash shell. The hash bang, the $, and then the exclamation point, is called a shebang. It just indicates that this is meant to be an interpreted script, and then the next section says the interpreter is bash. Here we're on the first conditional. This is what an if statement looks like in bash. It's doing the syntax check, the bit that says we need to make sure that we are accepting one argument. So we have an if statement, and then we have our two conditions. One condition is that the number of arguments passed must be exactly 1. If it's not equal to 1, then the test fails. Then we have an or, and then there's another condition, the first argument minus h. So if either one of these conditions is true, then we will follow the next two lines. We'll echo the usage statement, and we'll exit with exit code 1, which usually indicates an error. Next, we're reading the command line argument, which we pass, in this case etc/passwd, into a variable. The variable in this case is file. In bash, when you need to read a command line argument, it's always starting at $1. $0 indicates the shell file itself, the script itself. Next, we have a function. This is a reusable bit of code. We have an until loop. The purpose of this loop and this function is to determine when the answer is yes to the question, do you wish to parse the file? So until the answer variable contains either yes or no, this loop will just continually prompt, do you wish to parse the file? And then it will read the variable, and then it will test it again forever. Next, we have a conditional. If the answer was no, then we just exit. So if they don't wish to parse the file, then we'll exit. After that, the function just returns. Now we call the function using the parse prompt. So again, this isn't really how you would run a script in the real world. Most commonly, any code contained within a function will be called more than once. In this case, we're only calling it once for demonstration purposes. Finally, we get to the real meat of the script where the parsing happens. I always like to copy and paste an example of the line that I'm looking to parse, so I have it for a handy quick reference. So I've copied and pasted one of the lines from the etsy-passwd file here. Next comes the looping logic that sorts and prints out the parsed lines to the terminal. First, we sort the file by its user ID, and then we loop through each line, matching the desired fields and printing the output. So first, we have an example of running a command and piping it to the loop. We use the sort command to sort the file by the third field. So the field separator is passed to sort using -t, and -k indicates that it's the third field, and -n is the file that we wish to parse. In this case, etsy-passwd has been assigned to the file variable. We take the output of that sorted file and we pipe it to this while loop. The while statement reads each line at a time. The 3 lines starting with user followed by user ID and homedir parse the line. So we use the echo command to pipe the output to the cut command, which pulls out the first field. Next, we want the user ID, which, looking at our example line above, we can see is the third field, so we cut out the third field. Next up is the homedir. The homedir here is the 6th field, which you can count with those colon-delimited field separators. Once we have all 3 fields, we can echo that output to the terminal. Notice that we use $sign and then curly braces with the variable between them. This is a common way to use a variable in a script. Finally, just to demonstrate how a regular expression can work in Bash, we check that if a user ID contains at least 3 digits, then we print out this user has a UID with at least 3 digits. Finally, we close the loop with a done statement indicating that the loop is finished. So that's a simple Bash script. You'll find these all over Linux systems in order to automate and make more efficient many tasks.